Hello students, welcome again in our last parts for this chapter, in the last exercise of our derivative parts. Yes students, today I am going to our exercise 5, remaining questions, just few questions remaining here, and after that I am going to our miscellaneous examples. Yes students, in that part, question 18, if fx is given modulus of x cube, show that f double dash exists and find out it. It means up to 2 derivatives asking these questions. But students, question is given modulus. So we create two parts, one of the positive sides, one of the negative sides. So I first start, if x is positive either 0, both of the counted. So what is the fx? Only x cube, because in positive cases fx is positive for modulus. Now same as second case, if x less than 0, then same as to fx but in minus x cube, and both these are polynomial functions. So definitely our first derivative exists, second derivative also exists. So I am going to direct differentiation with respect to x. So here d dx of fx, d dx of x cube, and that is your f dash x, and here 3x square. First derivative easily done here. Now continue again differentiation with respect to x. So it is second order derivative. It is nothing, d dx of f dash x, and here also same, d dx of 3x square. So you did finally f double dash x, which is here 6x. Condition write down for x positive either 0. So this case is easily done. Here asking that exist means nothing. They are going to polynomial, and every polynomial function is a continuous and differentiable. That's why I create second order derivative. Now same as this side. Again by same differentiation with respect to x. So it is a d dx of fx, d dx of minus x cube. So here f dash x, here minus 3x square. Here first order derivative students easily done. And then after again differentiation with respect to x. So d dx of f dash x, it is nothing, f double dash x. I then write down first double dash, after that f dash x derivative. And this side also d dx of minus 3x square. So finally double dash derivative done is equal to minus 6x. And that answer is indicated for only condition. Which condition? Left hand side. X less than 0. Yes students, here our first case and second case easily done. Now I go into one more question. Now students, one more question. It is related PMI, means principle of mathematical induction. Using PMI, prove that d dx of x raised to n is equal to nx raised to n minus 1 for every n is a positive integer. Students, n is a positive integer means it is natural number, and this formula already known. Yes students, every formula for our derivative you can prove by using PMI. Here asking, that is one of the one, d dx x raised to n. So principle of mathematical induction you know, that's you first of all showing p of n. With whole question I just write down here d dx of x raised to n is equal to n of x raised to n minus 1 for every positive integer, means nothing n. Now I am going to first step. Yes students, step 1, step 2, step 3. So step 1, if n is equal to 1, so what's your p1 in the LHS? My LHS is a ddx of x raised to n. Only just putting n is 1. So ddx x raised to 1. My answer is only 1. And same going to I just the right hand side. So what is the RHS now? My RHS is a n into x raised to n minus 1. So 1 into x raised to 1 minus 1, which is x raised to 0. And sure, 1 into 1. So LHS is equal to RHS. It means sure P1 is true. So next step 2. If Pk is true, so students, P of k, this full P of n, I just translate in place of n, k value. So second step is as that d dx of x raised to k into x raised to k minus 1 for k belongs to next one. And then after, I just going to step 3, which is to prove and p of k plus 1. We know that k change in place of k plus 1 only. So d dx of x raised to k plus 1, here k plus 1, x raised to k plus 1 and minus 1. Generally, this cancel. It means we have to prove k plus 1, x raised to power 80 k. And now I start this LHS, left hand side. And using step 2, I derive that this RHS value. Yes, using step 2, don't take derivative direct. So, now LHS, my LHS is a d dx of x raised to k plus 1. Here students, I just separate the same power 80 addition, already given power 80 addition. That's why I convert the base same. Now, here consider one of the u and one of the v. It means our multiplicative rule. So first, second order derivative plus second first order derivative. And now, this are d dx of x raised to k. You know that here it is your step 2. And what is step 2 value? X raised to k, that is 1. And that is you known from step 2. K into x raised to k minus 1. Mention here because pk is true. Yes. Now base same. Again you check power 80 addition. So x raised to k, here this x raised to 1 and x raised to k minus 1. I just adding all into k. Now this 1 and this 1 only I have 1 into x raised to k plus x raised to k into k. Now what is the common? X raised to k common. So we have to only x raised to k common. Remaining 1 plus k, and sure that is my RHS. Yes, students, you never write down your direct derivative. We not utilize direct derivative because we prove by PMI. It means step 2 necessary we can use here. Now, after that write down. So P of k plus 1 is true. Continue. If Pk is true, then P of k plus 1 is also true. And that's your last saying by PMI. Pn is true for every positive integer, either natural number as you like. And yes, students, cover this 19 questions easily. Now students, one more interesting questions here coming. derive the formula using the fact of sin A plus B is equal to sin A cos B plus cos A sin B, and differentiation using derive the formula for cosines. Means students, nothing, you derive cos A plus B formula, utilize this one and apply derivative. So here given, already you know that sin A plus B is equal to sin A cos B plus cos A sin B, and this fact I utilize and apply the derivative with respect to x, and you derive cosine formula, means cos A plus B. So I start slowly differentiation with respect to x. Yes, so ddx of first data, left hand side part, and same is ddx of sin A cos B plus ddx of cos A sin B. And here students, you consider A and B both is a variable, not a constant here, huh? Yes. So left hand side derivative, sine derivative, which is cos A plus B into now A plus B. So dA by dx plus dB by dx. I just only respect to x, right? Here also same, both variable. So apply by product rule. So first d dx of cos B plus cos B d dx of sin A, and these are the only this today chain rule, product rule. After that I am going to chain rule. Here also same product rule. So first of all, cos A d dx of sin B, here like that, plus now sin B d dx of cos A, and that is here going to again to multiply. So we have to only cos A plus B dA by dx dB by dx, and here students now apply the chain rule. Cos B derivative first, after that B derivative with respect to x. So sin A here minus sin B, and B derivative dB by dx. Yes, same as cos B. Now sin A derivative first, sin derivative, and then after A derivative. So sin A derivative cos A, and A I have dA by dx. Yes, students, here are this case is first. Same as cos A. Now what is the sin B derivative with respect to x? It is cos B, and dB by dx is same. Similarly, sin B, here going to cos A derivative, and then after A derivative with respect to x. So minus sin A into dA by dx. So finally, we collect like terms. Look at that. These are dB by dx and this dB by dx. Both of the common taking. And same as dA by dx common taking. So you getting only cos A plus B and into dA by dx dB by dx. Students, right side, this dB by dx full term and this full term I just common taking. So remaining I have minus sin A sin B plus cos A cos B and dB by dx common take out to here and here. Same thinking, that dA by dx and here dA by dx common take, and remaining are cos A cos B minus this data and these are again same. You are going to take common carry. So we have only cos A plus B. dA by dx plus dB by dx. And here common checking. Minus sin A sin B plus cos A cos B. And what is the remaining? We have to remaining dB by dx plus dA by dx. Check these and this cancel. You getting only after that we write down that last step, that is cos of A plus B is equal to this value only. And I rewrite that cos A cos B minus sin A sin B, and sure you know that that is the derivation of cosine rule. Yes, students. Here the cos functions. Same as numerical students, you try extra for more practice. If sign of the fact A minus B, I just change here. That way total 4 different type of question asking. Here sin A minus B, sin A cos B minus cos A sin B, and derive cos of A minus B. Utilize by the derivative form and our simple formula. One more to numerical. If you cos A plus B given, after derivative you derive sin A plus B. And either cos A minus B given, then derive sin A minus B. So there are 4 types of different sums. You make the practice that way only. And students here over this sum. Yes, students. Yes, now students, we going ahead. One more parts. Here given the questions, justifying the questions, for that there exists a function which is continuous everywhere but not differentiable at exactly 2 points. Yes, students, focus about that. Not differentiable. It means you must be take that type of example. It is modulus, and 2 types of modulus we taking because I proved that 2 points they are not continuous. So suppose fx, you take out any 2 modulus terms. Students, before starting this numerical, I just clear about that. Here many examples you take out, but necessary in this modulus. Clear? And in any 2 points, here just I write down x minus 1, x minus 2. As you like, you also written x minus 3, x minus 4, x minus 5, any number. Also x plus 1, x plus 2 also written. Huh? Yes. I just only write down x minus 1 and x minus 2. And I check. This equal to 0 taking them, x equal to 1 and here x equal to 2. It means I check about x equal to 1 side and then after x equal to 2 sides. Continuity and differentiability. So case 1, at x equal to 1 I check. So if x less than 1 then x tends to 1 negative. Yes. And functions is that? Yes, x minus 1 and x minus 2 both I check. Here first x minus 1. Here apply minus 1 on both sides. So you getting only x minus 1 less than 0. So what is the modulus x minus 1? It is minus outside. Same as x less than 1. I just write down here minus 2. So you have to here less than minus 1. Indirectly, this also minus outside, and this value I utilize in my function. And limit, check, limit x tends to 1 minus fx. My fx is fixed, modulus x minus 1 plus modulus x minus 2, and here apply your minus value and here minus value. So limit, this value is a minus of x minus 1 and minus of x minus 2, and that expanded. You getting one of the value for x. So limit x tends to 1 minus, it is minus x plus 1 minus x plus 2, and finally it is getting how many? 3 minus 2x. Yes, limit x tends to 1 minus, it is 3 minus 2x, and I apply 3 minus 2, x is 1, I getting only 1. These are the first case. First part, left hand side part over. Now continue again when if x more than 1, then x tends to 1 positive. Students, I here only checking about x equal to 1, and then after similarly x equal to 2 we go in. So here also same create x minus 1 both side subtract it because I utilize the value. So here x minus 1 more than 0. So what is the modulus of x minus 1? It is the positive because positive side is coming. Same as here. If I getting x minus 1, here 2 subtracted. So it is x minus 2 is here greater than minus 1. Minus 1 to more than side going. It means negative number also exists, 0 number also exists, and positive number also exists. Here total are going to some negative number, some positive number. I just write down modulus x minus 2, here minus negative sign because some negative number also exists there. Now limit x tends to 1 positive fx. Similarly, the function is x minus 1, this one, and plus x minus 2. Same apply. This number is x minus 1 and here x minus 2. So I just create the one of the value x minus 1 minus x plus 2. Sure, the answer is 1. Check. These both are same. So it is your continuous, just I check now. After that I go into our differentiability. It means definition for derivative. That case I direct write down, don't worry. So after that I just check to differentiable at x is equal to 1. So students, here case 1 is running in the differentiability. After now going to I, now f dash x, limit x tends to 0, f of x plus h minus fx by h. That you know the formula, our basic formula for derivative. I check at x is equal to 1. So at x is equal to 1. What is the f dash x? Limit x tends to 0, left hand side, f of x plus 1 minus f1 upon h. Yes students, these are the one case. And after that putting in the fx, our modulus of x minus 1, x minus 2. And similarly, you also write down next one, x tends to 0 positive, f of x plus 1 minus f1 by h. This case you direct write down. If you calculate this left hand side case and right hand side case, in the derivative wise, the limit is both different. That not showing here, I direct write down. So here x equal to 1 at fx is this one. Fx is not differentiable this point. And after that you write down similarly at x is equal to 2. Continuity check. It is a continuous. But at x equal to 2, here 2 just f2, here 2, f2 is also not differentiable. So similarly limit, I just show you directly here, limit x tends to 0 negative, f of x plus 2 minus f2 by h is not equal to. Students, here I just write down direct step. Don't worry, you also write down an exam also direct. It's possible because in this numerical there are many types of functions. You showing only one, and after that we are going to similarly this and this case. Either you calculate by the definition wise both derivative. I am sure both derivative answer is a different way. Yes, students, and here about this numerical is done. If you take in here, note that if you are taking modulus of some time x minus 3 and x minus 4, then what you create here? X tends to here 3 plus 3 minus, maybe 3, 4 plus 4 minus, but 2 modulus taking necessary. Yes, here about this numerical is a done. Now students, we going ahead one more questions for the determinant related. And derive that is of our indeterminate, but here derivative f dash x, g dash x, I dash x. So we have to first of all y. I expanded by the definition L, M, N and A, B, C. Yes, students, I am going to row wise or column entry and expand by definitions. So what is the expansion? Fx minus gx and last hx. That's our simple definition rule. Here M and BC. Second L and AC. And last LM but AB. Now go to expansion. We have to one of the expansion here M into C minus B into M. Same as L into C minus A into M. And last Hx L into B minus A into M. Here students, our expansion over. Now I want to derivative. So differentiation with respect to x, and that is your dy by dx. Yes, here m into c minus b into n d dx of fx. Same as that is the d dx of gx, and same as lb minus am d dx of hx. And here students, our derivative easily done because dy by dx is a mc minus dm, and here f dash x same lc minus am g dash x and lb minus am h dash x, and that is nothing. It is your original form of our 3 cross 3 determinant. So dy by dx, that's your f dash x, g dash x and h dash x. I just only write down that our row. Other are L, M, N same, and other are ABC, and that is your easily our turn for this numerical. Now I will ahead next one, students. Yes, now students, one more interesting question, and it's the last question for our this exercise. Given that this y e into a cos inverse x in the condition -1 to 1, prove that in the first order, second order function. So students, first of all, y e is to a cos inverse x. I just here taking my statement to 1. So I just start differentiation with respect to x. It is dy by dx. Either you can call here y1, and that is the d dx of e raised to a cos inverse x derivative. So you getting only e derivative same and this derivative. a into cos inverse x. And that you know? Yes, dy by dx. Students, these are known you. It is your question. Statement 1. Why? And here derivative is a minus 1 by under root 1 minus x square. Cos inverse x derivative. Now, this root function I just remove. It means taking square on both sides. Taking square on both sides. So, you have to only dy by dx square, here y square, a square, and that is same 1 minus x square. Now just I cross multiply on it. We getting 1 minus x square dy by dx square and is equal to a square into y square. And here students start our second order derivative. So differentiation with respect to x. So first, second order derivative here ddx of dy by dx square. Now second ddx of 1 minus x square. Only here apply our product rule. Here also same is equal to a square ddx of y square. Now y square ddx of a square. And now operate our derivative. So here 1 minus x square same. Now what is the dy by dx square? 2 into dy by dx into now dy by dx derivative. It is a square y by dx square. Again repeat students. First I am taking power into derivative. 2x raised to 2 and 2 minus 1. That here write 2 dy by dx raised to 2 minus 1. And second now dy by dx derivative. Plus here same. It is 0 minus 2x. And is equal to same as a square. Here 2y. Y derivative dy by dx, and here constant. In constant derivative, no, it is 0. Now overall, you have to take in common 2 into dy by dx. Not equal to 0, we divide. Yes, students, this dividing each term 2 into dy by dx. So you getting only 1 minus x square. This gone. Only d square y by dx square minus x same only dy by dx because here 2 gone 1 dy by dx gone and is equal to a square into y. Check, that's your result. This result. The last I just showing that 1 minus x square d square y by dx square x dy by dx and minus a square y is equal to 0. And that's our students, this question is happily done. Same as you try itself. Here just I change sin inverse x. Derivative same. Only here positivity. After that same steps. And here students, our this are 23 questions easily done. Yes students, here our exercise over. And this part is also over here students. I explain you in other parts, in the next parts, our remaining miscellaneous exercise and remaining exercise 5.8. Yes students, now till up to today over. Bye bye, see you.